Today we will learn laws of exponents. In mathematics and science, it is often necessary to carry out various operations on exponents. To get the correct result of these operations, we need to understand the laws of exponents. In the previous class, we learnt that for non-zero integer a and b and whole numbers m and n, the following rules apply. Just think, will this rule also apply to numbers whose exponents are an integer and the base is a rational number? Think a little. Let's find out. The rule a to the power m into a to the power n is equal to a to the power m plus n will be the first to be discussed. Suppose we take the value of a as a rational number such as 7, the value of m is integer minus 2 and the value of n is integer minus 3. So the left side will become 7 to the power minus 2 into 7 to the power minus 3 and the right side will become 7 to the power minus 2 plus minus 3 whole is equal to 7 to the power minus 5. Let us find out whether the value of both the sides are equal or not. We can write 7 to the power minus 2 as 1 upon 7 to the power 2, that is 1 upon 7 into 7. Similarly, 7 to the power minus 3 can be written as 1 upon 7 into 7 into 7. We can express the multiplication of these two numbers as 1 upon 7 into 7 into 7 into 7 into 7's form. Since 7 is multiplied by itself 5 times in the denominator, we can write 7 to the power 5 in place of the denominator so that we get the number 1 upon 7 to the power 5, which can be written as 7 to the power minus 5. Now as you can see, the values of both sides are equal. That is, this rule is also true for integer exponents. In this way, we can say that a to the power m into a to the power n is equal to a to the power m plus n. This rule will also be applicable for numbers whose base is a rational number and the power is an integer. That is, it is true as a to the power m into a to the power n is equal to a to the power m plus n for a rational number a and integers m and n. Now let's talk about a to the power m divided by a to the power n is equal to a to the power m minus n. Here, if we take a is equal to 7, m is equal to minus 2 and n is equal to minus 3, we get 7 to the power minus 2 divided by 7 to the power minus 3 is equal to 7 to the power minus 2 minus 3. Let's find out whether the left side and right side are also equal here. For this, we will simplify the two sides and compare the results obtained. By simplifying the right side, we will get 7 to the power minus 2 plus 3 is equal to 7 to the power 1. Now we will simplify the left side. 7 to the power minus 2 divided by 7 to the power minus 3 is equal to 1 upon 7 to the power 2 divided by 1 upon 7 to the power 3. Can you tell how will we simplify this division now? Give it a thought. Let's find out. Do you remember that when we divide rational numbers, we keep the first number as it is, then replace the division symbol with the sign of multiplication and take the reciprocal of the second number. Here, the inverse of 1 upon 7 to the power 3 will be 7 to the power 3. This gives us 7 to the power minus 2 divided by 7 to the power minus 3 is equal to 1 upon 7 to the power 2 into 7 to the power 3. Since 7 to the power 2 is equal to 7 into 7 and 7 to the power 3 is equal to 7 into 7 into 7, we will deduct 2 7s from the denominator and 2 7s from the numerator. From this, we will get the result 7 to the power 1, which is equal to the right side. Here also it is verified that for the rational numbers a and b and for integers m and n, a to the power m divided by a to the power n is equal to a to the power m minus n. This rule is true. Now the rule a to the power m whole to the power n is equal to a to the power mn will be discussed. Suppose we take a is equal to 1 upon 2, take m is equal to -1 and n is equal to 2. Under the rule we can write 1 upon 2 whole to the power -1 whole to the power 2 is equal to 1 upon 2 to the power -1 into 2. Let's simplify both sides here too. We can write the left side as follows. 1 upon 2 to the power -1 whole to the power 2 is equal to 1 upon 2 to the power -1 into 1 upon 2 to the power -1. 1 upon 2 to the power -1 means 1 upon 2's reciprocal, that is 2. So we can write it as 1 upon 2 to the power -1 whole to the power 2 is equal to 2 into 2 is equal to 4. Now simplify the right side. Since both the sides are equal, it is verified that for rational number a and integer numbers m and n, a to the power m whole to the power n is equal to a to the power mn. Similarly, you can check the remaining rules. On checking, you will find that all the rules are true even for numbers whose base is rational number and power is integer. By knowing all these rules, we can easily solve the examples related to exponents. So we can say that for rational number a, b and integer m and n, a to the power m into a to the power n is equal to a to the power m plus n. A to the power m divided by a to the power n is equal to a to the power m minus n. A to the power m whole to the power n is equal to a to the power mn. A to the power m into b to the power m is equal to a into b whole to the power m. A upon b to the power m is equal to a to the power m upon b to the power m. A to the power 0 is equal to 1. Today we learned some exponent rules. In the next video, we will see some related examples.
Today we will see examples related to laws of exponents. Example simplify. 5 upon 6 whole to the power -12 into 4 upon 15 whole to the power -12 whole to the power 3. To simplify this, we need the understanding of the laws of exponents. Pause the video and revise them again. Here we see that two exponents are being multiplied in brackets whose bases are different, but the powers are the same. To simplify it, tell us which rule should we use? Give it a thought. Exactly, we will use this rule. A to the power m into b to the power m is equal to a into b whole to the power m. In this way, we can write 5 upon 6 whole to the power -12 into 4 upon 15 whole to the power -12 is equal to 5 upon 6 into 4 upon 15 whole to the power -12. Now if we simplify the multiplication given in the brackets, we will divide 15 by 5 so that instead of 15, we get the number 3. Similarly, we give 4 and 6 as their m, that is, 8CF divided by 2, we get 3 instead of 4 and 3 instead of 6. Then we will find the result of multiplication. For this, we will multiply the numerator, which will come 2, and similarly we will multiply the denominator, which will come 9. In this way, multiplication will result in 2 upon 9. In this way, the given question will become 2 upon 9 whole to the power -12 whole to the power 3. Can you tell to solve this what all rules need to be used by us? Give it a thought. Okay, I will tell you. Here, the rule a to the power m whole to the power n is equal to a to the power mn will be used. By using this, 2 upon 9 whole to the power -12 whole to the power 3 can be written as 2 upon 9 whole to the power 3 into -12 whole. 3 into minus 12 is equal to minus 36, then solution of the given question is 2 upon 9 whole to the power minus 36. By using the rules correctly like this, you can solve difficult questions in minutes. Next example, find the value of x so that minus 27 to the power minus 7 divided by 9 to the power x minus 6 is equal to minus 3 to the power 3. You must be aware of the fact that in an equation both the sides are of equal value. Here, if we somehow equate the bases of both the sides, then we can compare the powers. Along with this, we can also find the value of x. Come, let us solve it this way. All of you know by now that minus 27 can be written as minus 3 into minus 3 into minus 3, which in exponential form is written as minus 3 to the power 3. In this way, to get an equal base for the first value, we can write 9 as minus 3 into minus 3, that is minus 3 to the power 2, minus 3 to the power 3 whole to the power minus 7 divided by minus 3 to the power 2 whole to the power x minus 6 is equal to minus 3 to the power 3. Here the rule a to the power m whole to the power n is equal to a to the power mn will be used. Then we will get minus 3 to the power 3 into minus 7 whole divided by minus 3 to the power 2 into x minus 6 whole is equal to minus 3 to the power 3 minus 3 to the power minus 21 divided by minus 3 to the power 2x minus 12 is equal to minus 3 to the power 3. Now here we can see that the bases are equal. On the left side, the rule a to the power m divided by a to the power n is equal to a to the power m minus n can be used by us. This will give us minus 3 to the power minus 21 minus 2x minus 12 whole is equal to minus 3 to the power 3 is equal to minus 3 to the power minus 21 minus 2x plus 12 is equal to minus 3 to the power 3 minus 3 to the power minus 9 minus 2x is equal to minus 3 to the power 3. Because the value of both the sides is equal and the bases of the sides are equal too, thus the powers would be equal too. So we can say that minus 9 minus 2x is equal to 3. That is, minus 2x is equal to 3 plus 9 is equal to 12. That is, x is equal to 12 divided by minus 2 is equal to minus 6. So here, the value of x is minus 6. Today we saw examples related to laws of exponents. In the next video, we will see some common mistakes made in this concept.
Today we will see some of the common mistakes related to the rules of exponents. Mistake 1. Simplify 6 to the power 5 upon 6 to the power minus 2. Some children do not use the rules of exponents properly. They know that a to the power m upon a to the power n is equal to a to the power m minus n, but do not use it correctly. Not focusing on the signs, they, instead of subtracting minus 2 from 5, they subtract 2 out of 5 and get the answer 6 cube, which is an incorrect answer. Keep in mind that 5 minus 2 whole is equal to 5 plus 2 is equal to 7. So the simplified form of the given question will be 6 to the power 7. Mistake 2. Simplify 9 to the power 6 whole to the power minus 2. Some children, while finding the answers to this question, due to not knowing the rules, end up subtracting 6 and minus 2. This gives them the wrong power of 9, which is 4. On solving this, they answer 9 to the power 4, which is a wrong answer. The power of the power is given here. We multiply both powers whenever the power of the power is given. That is, a to the power m whole to the power n is equal to a to the power mn. Hence, the correct answer to this question is a to the power 6 into minus 2 whole is equal to 9 to the power minus 12. Mistake 3. Minus 2 to the power minus 2 whole to the power minus 2 whole to the power 0 into minus 2 to the power minus 2 whole to the power minus 2 whole to the power 0 is equal to 1. Identify this statement as true or false. Some children do not know that when the power of a number is 0, its value is 1. They think that when the power is 0, then the value of the number is also 0. Because of this false belief, they understand that the given statement is false, but this is a correct statement. Suppose we have to find the result of a to the power m divided by a to the power m. Can you tell what will be the result? Give it a thought. Absolutely right. Since the values of both the numerator and the denominator are equal, the result will be 1. That is, a to the power m divided by a to the power m is equal to 1. Now let's solve the left side. Here we can write a to the power m divided by a to the power m is equal to a to the power m minus m. That is, we can write a to the power 0. In this way, we will get a to the power 0 is equal to 1. So keep in mind that whenever the power of a number is 0, its value is 1. Now look at the example given. Here power 0 is written on top of both the brackets. This means that whatever the number is inside the brackets, since the power is 0, so the result will be 1. And we know 1 into 1 is equal to 1. Since the left side is equal to the right side, the given statement is true. Some children solve the whole statement to get the result. Although they get the right answer, it takes them a long time to find it. While solving any question, it is necessary to see how we solve the question so that we get the answer quickly. Today we saw some of the common mistakes related to the rules of exponents. Today we will learn about numbers with integers as exponents. In the previous class, we learned to use exponential form to write large numbers in exponential form. Do you remember? Let's revise it. If a number a is multiplied by m times itself, we get the number b. Then we express the number b in an exponential way and read it as a raised to the power m. We call the number a as the base and the number m is the exponent of the number a. Like, we have the number 128 when 2 is multiplied 7 times by itself. So we express 128 as 2 to the power 7. It has 2 as base and 7 is an exponent. In the previous class, we also learned about the standard form of number. You must remember that if we express a number n as m into 10 to the power p, where m is greater than equal to 1.0 but smaller than 10 and p is an integer, then this form of the number is called its standard form. The standard form is helpful in shortening any number. N is equal to m into 10 to the power p. For example, the speed of light is about this much, which we represent in standard form by 3.0 into 10 to the power 8 meter per second. We can express 32 as 2 to the power 5. Here, 2 is the base and 5 is the exponent. If we divide 32 by the base 2, we get the number 16, which we denote by 2 to the power 4. As you can see, the exponent is reduced by 1 once the number is divided by 2. Similarly, if we divide 16 by 2, we will get the number 8, which is in the exponential form 2 to the power 3. Here also you can see that the exponent has decreased by 1. Similarly, if we keep dividing the obtained numbers by 2, on the other side, we will have to reduce the exponents by 1. This will give us this pattern. Now, if we divide 1 by 2, then again we have to subtract 1 from 0, which will result in -1, that is, 1 upon 2 is equal to 2 to the power -1. If we divide this number by 2, we will get the number 1 upon 2 into 2 is equal to 1 upon 4. Since we have divided by 2, we will reduce the exponent by 1. That is, -1 minus 1 is equal to -2. In this way, 1 upon 4 is equal to 2 to the power -2. Can you tell what will be the next step in this pattern? Give it a thought. Exactly. Here we will again divide by 2 and the exponent will be subtracted from 1 again, from which we get 1 upon 8 is equal to 2 to the power -3. In this way, by following the pattern, we will get the number 1 upon 16 is equal to 2 to the power -4. 1 upon 32 is equal to 2 to the power -5, and so on. As you can see, the exponential can be positive, it can be 0, and it can also be negative. That is, the exponent of numbers can be an integer. Using integer exponents, we can express very large numbers as well as very small numbers in exponential form. For example, the mass of a small particle of dust is how many kilograms. This can be expressed easily by shifting the decimal point 10 places to the right, that is 7.53 into 10 to the power -10. Do you remember that the product of the number a and the number 1 upon a is 1? So we refer to a and 1 upon a as multiplicative inverse. For example, if we talk about the numbers 32 and 1 upon 32, their product is 1. So they are multiplicative inverse of each other. Now, as you know, we can write 32 as 2 to the power 5 and 1 upon 32 as 2 to the power -5. With this, we can also call 2 to the power 5 and 2 to the power -5 as multiplicative inverse of each other. With this understanding, we can express number 2 to the power 5 as 1 upon 2 to the power -5 and number 2 to the power -5 as 1 upon 2 to the power 5. Broadly, any number a to the power m can be expressed as 1 upon a to the power -m and number a to the power -m as 1 upon a to the power m. An understanding of exponents helps us to write expanded form. For example, if we need to write an extended form of 2365.985, we can do this as follows. As you can see here in this table, we have shown the digits in their respective places. Depending on their positions, we can expand this number as follows. 2365.985 is equal to 2 into 1000 plus 3 into 100 plus 6 into 10 plus 5 into 1 plus 9 into 1 upon 10 plus 8 into 1 upon 100 plus 5 into 1 upon 1000. Here we can write 100 as 10 to the power 2 and 1000 as 10 to the power 3. With the understanding of multiplicative inverse, we can write 1 upon 10 as 10 to the power -1, 1 upon 100 can be written as 10 to the power minus 2 and 1 upon 1000 can be written as 10 to the power minus 3. Therefore, we can write the given number in expanded form as follows. So today we learned about numbers with integer as exponents. In the next video, we will see some interesting examples related to them. Today we will see some examples of numbers with integers as exponents. Example 1. Generally, there are 100 billion cells in a human body. Express this number in exponent form. To express in exponents, we must first express this number in digits. Since 1 billion is equal to 1,000,000,000,000, so 100 billion is equal to 100 into 1,000,000,000,000. Here, every zero represents multiplication by 10. Since the total number of 0 here is 11, we can say that multiplying 10 by itself 11 times, we will get this number. In this way, we can express the given number as 10 raised to the power 11. Example 2. Express the number 2137.69 in expanded form. First of all, we will show this number in the place value table. As you can see here, 2 is in the thousands place. So its value will be 2 into 1000. Similarly, 1 is in place of hundreds, so its value will be 1 into 100. Following it, the value of 3 is 3 into 10. The place value of 7 is 7 into 1. Can you tell what will be the place value of 6 here? Give it a thought. Absolutely correct. 6 is in the decimal ones place, so its place value is 6 into 1 upon 10. Similarly, 9 being at the place of decimal 2, its place value will be 9 into 1 upon 100. Expanded form of a number is obtained by expressing the place values of the digits as a sum. That is, we can express 2137.69 in this way. As you know, to write 1000 to 10 to the power 3, 100 to 10 to the power 2, 10 to 10 to the power 1, one can write 10 to the power minus 1 as 1 upon 10 and 1 upon 100 as 10 to the power minus 2. With this, the extended form of the given number can be written 2 into 10 to the power 3 plus 1 into 10 to the power 2 plus 3 into 10 to the power 1 plus 7 into 10 to the power 0 plus 6 into 10 to the power minus 1 plus 9 into 10 to the power minus 2. Next example 3. Rahul wrote the multiplicative inverse of 5 to the power minus 12 as 5 to the power 12. Find out whether Rahul's answer is correct or not. The multiplicative inverse of a number is the number with which multiplying the number gives the result 1. The multiplicative inverse of a number b is written as 1 upon b. Suppose b is equal to a to the power m, then in such case a multiplicative inverse of b will be written as 1 upon a to the power m, that is a to the power minus m. With this understanding, we can write multiplicative inverse of 5 to the power minus 12 as 1 upon 5 to the power minus 12 is equal to 5 to the power 12. So we can say that Rahul has given the correct answer. Next example. Express the following number in exponential form. We can write the given number as 1 upon 3 into 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 3. Here you can see that in the denominator 3 is multiplied by itself 8 times. So we can write 3 to the power 8 in place of denominator. You will also know that we can write a number 1 upon a to the power m as a to the power minus m in this way. So we can write 1 upon 3 to the power 8 as 3 to the power minus 8. From this, we will get the exponential form of the given number 3 to the power minus 8. Today we saw examples of numbers with integer as exponents. In the next video, we will see some misconceptions related to them. Today we will see some misconceptions and mistakes related to numbers with integers as exponent. Misconceptions 1. Find the multiplicative inverse of the number 8 to the power minus 2. Some children write a multiplicative inverse of this exponential number as 1 upon 8 to the power 2. The reason for this is that they do not understand how multiplicative inverse of exponents is written. Some children get confused when the exponent is negative. They think that to write a multiplicative inverse of an exponential number such as 8 to the power minus 2, the number is written by replacing the numerator by 1 and denominator, the exponent is written after changing the sign. With this understanding, they get a multiplicative inverse of 8 to the power minus 2 as 1 upon 8 to the power 2 and choose option 1 as the answer, which is an incorrect answer. Some children write a negative sign of the exponent before the number to get a multiplicative in base, which gives them a multiplicative inverse of 8 to the power minus 2 as minus 8 to the power 2. So they select option 2, but it is a wrong answer too. Some children also get confused in multiplicative inverse and additive inverse. They consider minus 8 to the power minus 2 as a multiplicative inverse of 8 to the power minus 2 and choose option 4 as the answer. But minus 8 to the power minus 2 is an additive inverse of the number 8 to the power minus 2 and not a multiplicative inverse. So option 4 is also incorrect. Remember that the multiplicative inverse of a number a to the power m is a to the power minus m. For this reason, the multiplicative inverse of 8 to the power minus 2 is 8 to the power 2. Hence, option 3 is the correct answer. Misconception 2. Minus 4 to the power 2 is equal to which of the following number? Some children do not know the concepts of negative numbers and negative exponents properly. They think that minus 4 to the power 2 is equal to minus 4 into minus 4 is equal to 16. But this is a misunderstanding. Choosing option 1 with this understanding is an incorrect answer. Here brackets are not used, which shows that the power is only of 4 and not the minus sign. Therefore, it is right to write minus 4 to the power 2 is equal to minus 4 into 4 in brackets, which gives us the correct result, minus 16. Hence, option 2 is the correct answer. It is important that if minus 4 to the power 2 were written here, it would have been written as minus 4 into minus 4, which would have resulted in 16. So it is important to notice that the exponent given to us in the question is of which number. Now let's see a simple mistake. Some children do not understand the importance of exponents, minus sign, and ignore it, as they understand that a to the power minus m can also be written as a to the power m. But this is a misunderstanding. Let's understand this. For this, we will take a number 2 to the power minus 3. As you will know, 2 to the power minus 3 is equal to 1 upon 2 into 2 into 2 is equal to 1 upon 8, which we can write as 0.125 in decimal form. Now, if we talk about 2 to the power 3, then we can write it as 2 into 2 into 2, that is 8. Are both the values equal? Give it a thought. No. Therefore, we cannot write 2 to the power minus 3 as 2 to the power 3. Therefore, it is important to pay attention to the sign of the power. So today we saw misconceptions and mistakes related to numbers with integers as exponents.
Today, we will learn the standard form of numbers. Many times we encounter a number which is difficult to read and write. It becomes difficult to perform any operations also. In such a case, the standard form of a number helps us out. We can express any number n using exponent as m into 10 to the power of p, where m is equal to or greater than 1.0 but less than 10.0 and p is an integer. This form of a number is called its standard form. We also call it the scientific notation of a number. For example, we can write this number as 4.5 into 10 to the power of 6 in standard form. Let's find out how to find the standard form of a number. We can represent this number as 4.5 into 10 lakh. We can write this in exponent form as follows. Now, we see that the value of m is 4.5 and this number is greater than 1.0 and less than 10.0. Similarly, the value of p is 6, which is an integer. So, this is how we identify the standard form of this number. Now let us look at this number. We can represent this number as follows. We write this in exponential form as follows. Now, we see that the value of m here is 4.5, which is greater than 1.0 and smaller than 10.0. And the value of p is minus 5, which is an integer. In this way, it is the standard form of this number. Let us now find out how to write large numbers in standard form. Suppose we have to write this number in standard form. We have to represent it in the form of m into 10 to the power of p, where m is greater than 1 and less than 10.0 and p is an integer. For this, we will first place a decimal point on its right side. We can see that moving the decimal point 12 places towards the left, we get the number 3.45, which is greater than 1.0 but smaller than 10.0. In this way, 3.45 is the value of m. Since we moved the decimal point 12 places towards the left, we will multiply this number by 10 to the power of 12 so that there is no change in the value of this number. In this way, the value of p here is 12. This gives us the standard form of this number as 3.45 into 10 to the power of 12. Now let's find out how very small numbers can be written in standard form. Now if you are given a very small number of this type, then will you be able to write it in standard form? Give it a try. Let me tell you, we have to represent this as m into 10 to the power of p, where m is greater than 1 but less than 10.0 and p is an integer. We see that when the decimal point is moved 9 places towards the right, we get the number 8.76, which is greater than 1.0 but smaller than 10.0. In this way, we can write 8.76 in place of m. Since we have moved the decimal point 9 places towards the right, we will multiply this number by 10 to the power of minus 9, so that there is no change in the value of the number. In this way, the value of p here is minus 9. This gives us the standard form of this number as 8.76 into 10 to the power of minus 9. Today, we learned the standard form of a number. In the next video, we will see some interesting examples related to this. Today, we will see some interesting examples related to the standard form of numbers. If 1 day's food consumption of an elephant is 3 lakh gram, then how can you express 1 year's consumption of the elephant in standard form? Here, we have to write 1 year's consumption of elephant in the standard form. The standard form of a number is written in the form of m into 10 to the power of p, where m is greater than or equal to 1.0 but less than 10.0, and the number p is an integer. In 1 day, the elephant consumes 3 lakh gram. We know that there are 365 days in a year. So, we will multiply 365 and 3 lakh gram. In this way, 1 year's consumption of the elephant is equal to 365 into 3 lakh gram. We can write 3 lakh as 3 into 10 to the power of 5 in exponential form. In this way, 1 year's consumption of elephant is equal to 365 into 3 into 10 to the power of 5 grams, which is equal to 1095 into 10 to the power of 5 grams. We have to write the number in standard form. Therefore, we will place the decimal point on the rightmost side of 1095 and move it 3 places to the left. Since we have moved the decimal point 3 places to the left, we will multiply the number by 10 to the power of 3 to keep the value of the number same. So, 1 year's consumption of the elephant is equal to 1.095 into 10 to the power of 3 into 10 to the power of 5 grams. Can you tell us which exponential rule can we use to write it in simpler form? Think for a while. You got it right. We will use the rule a to the power of m into a to the power of n is equal to a to the power of m plus n. With the help of this, we can write 10 to the power of 3 into 10 to the power of 5 is equal to 10 to the power of 3 plus 5, which is equal to 10 to the power of 8. Using this, we can say that 1 year's consumption of elephant is equal to 1.095 into 10 to the power of 8 grams. Comparing this to m into 10 to the power of p, we get to know that the value of m here is 1.095, which is greater than 1.0 but smaller than 10.0. Similarly, the value of p is 8, which is an integer. Thus, by finding out the 1 year's consumption of the elephant, we have expressed it in standard form. Next example. The mass of a proton is 1.672623 into 10 to the power of minus 27 kg. And the mass of an electron is 9.109390 into 10 to the power of minus 31 kg. Compare the mass of both. We can compare them in different ways. We can determine which one has a higher mass among them. Similarly, we can also find out how many times is the mass of one greater than the mass of the other. Let's look at the first method. Which number is greater or smaller amongst the two exponential numbers? To find this out, we equate the units and exponents. Here, the units of both are the same. But for 1.672623 into 10 to the power of minus 27 kg, the power is minus 27, whereas for 9.109390 into 10 to the power of minus 31 kg, the power of this number is minus 31. To equate the exponents, we will either have to make the power of both as minus 27 or minus 31. Let's make the power of both as minus 31. Can you tell, in the number 1.672623 into 10 to the power of minus 27 kg, what do we need to do to make the power of this number to minus 31? Think for a while. Let me tell you. We will have to move the decimal point 4 places to the right, and to ensure that the value of the number doesn't change, we will have to reduce its power. Here, minus 27 is a negative integer, so we will subtract 4 from minus 27 so that we get the power as minus 31. Now the mass of the proton is 16,726.23 into 10 to the power of minus 31 kg, and the mass of the electron is 9.109390 into 10 to the power of minus 31 kg. Since powers and units are the same, now we can compare them. Here, we see that 16,726.23 is greater than 9.109390. So, we can say that 16,726.23 into 10 to the power of minus 31 kg is greater than 9.109390 into 10 to the power of minus 31 kg. That is, the mass of a proton 1.672623 into 10 to the power of minus 27 kg is greater than the mass of the electron. Now let's compare these in terms of multiples. For this, we will divide the mass of one by the mass of the other. Mass of proton divided by mass of electron is equal to 1.672623 into 10 to the power of minus 27 kg divided by 9.109390 into 10 to the power of minus 31 kg. Try this division yourself. You can use a calculator. We will get the result of this division as approximately 1836.15. In this way, we can say that the mass of a proton is about 1836.15 times greater than the mass of an electron. Now, you can find out the mass of an electron in comparison to that of a proton. So today, we saw some interesting examples related to the standard form of numbers. In the next video, we will clear some misconceptions related to them. Today, we will see some misconceptions related to the standard form of numbers. Misconception 1. In the class, the teacher asks the students to write the number 0.000356 in standard form. Meena wrote the number as 356 into 10 to the power of minus 6 in standard form. Raj wrote the number as 3.56 into 10 to the power of minus 4 in standard form, and Rohit wrote the number as 3.56 into 10 to the power of 4 in standard form. Find out who wrote the number correctly in standard form. Some children are not able to understand the difference between the exponential form and the standard form of a number. They think that the exponential form of a number is the standard form. Like, we can write the given number in different ways like this. They can see that Meena's and Raj's answers are amongst these, so they think that option 3 is the correct answer. Since not every exponential form is the standard form, option 3 is an incorrect answer. Some children know that if the standard form of a number which is less than 1 is to be obtained, then the decimal point is to be moved to the right so that the number can be written in the form of m into 10 to the power of p, where m is greater than or equal to 1 and lesser than 10, and p is an integer. For example, here Raj has moved the decimal point 4 places to the right, and to retain the same value of the number, multiplied it by 10 to the power of minus 4. So here, the correct answer is option 1. Some children do not correctly indicate the exponent sign while doing so. They think that a to the power of minus n and a to the power of n are equal. Like here, Rohit's understanding is that 10 to the power of minus 4 and 10 to the power of 4 are equal. But this is an incorrect understanding because 10 to the power of minus 4 means 0.0001 and 10 to the power of 4 means 10000. That is, option 2 is also an incorrect answer. Note that a to the power of minus n and a to the power of n are not equal. For example, 8 to the power of minus 3 is equal to 1 by 8 into 8 into 8, which is equal to 1 by 512, whereas 8 to the power of 3 is equal to 8 into 8 into 8, which is equal to 512. Do you think the result is same in both the cases? No. Therefore, a to the power of minus n and a to the power of n are not equal. Misconception 2. The grain storage capacity of tank A is 3 lakh gram and the grain storage capacity of tank B is 2 lakh kg. Compare the storage capacity of both the tanks. Here, the storage capacity of tank A is 3 lakh gram and the storage capacity of tank B is 2 lakh kilogram. The storage capacity of both the tanks is to be compared. Some children see that the storage capacity of tank A is 3 lakh, that is 3 into 10 to the power of 5, and the storage capacity of tank B is 2 lakh, which is 2 into 10 to the power of 5. The attention of the students does not go towards the units. Their focus is only on the number, like the number 3 into 10 to the power of 5 is greater than the number 2 into 10 to the power of 5. So, they think that the storage capacity of tank A is higher than the storage capacity of tank B. That's how they choose option 1, which is incorrect. We must focus on the units of the numbers. Here, the grain storage capacity of tank A is in grams and the grain storage capacity of tank B is in kg. Both the numbers must be in the same units for comparison. We know that 1 kg is equal to 1000 grams, that is equal to 10 to the power of 3 grams. Hence, 2 into 10 to the power of 5 into 10 to the power of 3 is equal to 2 into 10 to the power of 8. That is, the storage capacity of tank B is 2 into 10 to the power of 8 grams, which is greater than 3 into 10 to the power of 5 grams. So the correct answer is option 2. Today we saw some misconceptions related to the standard form of numbers.